You know, getting a huge project done on time and on budget, it's not just about having a pretty Gantt chart. It's about how that plan actually connects with the folks out there building it. That connection, that interface between the planning office and the construction site, that's everything. It's where projects either fly or fail. So today, we're going to dive into how you turn that static plan into the living, breathing heartbeat of your project.
Okay, get this quote in your head. Commissioning milestones drive construction, construction milestones drive engineering. That right there, that's the whole philosophy in a nutshell. It's the secret sauce behind what we call a construction-driven approach. So instead of starting at A and moving to B, we're going to flip the whole thing on its head. We start at Z, the finished, running facility, and work our way backward. Let's unpack what that really means.
So, what does it actually feel like to be on a team that's using this construction-driven approach? Well, it's a pretty major shift in how you think about, well, everything.
It all comes down to reverse engineering the entire project. Think about it. You start with the absolute final step, flipping the switches and commissioning the plant. The sequence you need to follow to turn it all on, that dictates the order you have to build things in. And that, in turn, tells engineering what to design first and procurement what to buy first. Everything is laser-focused on that finish line from day one.
Right, so a project schedule, it's not some document you write, laminate, and stick on a wall. Nope, it's a living, breathing thing. It has to evolve and get sharper and more detailed as the project itself goes from a sketch to a real thing. There's a fancy term for this, progressive elaboration. Let's take a look at how that actually works.
Look at this timeline. Construction input doesn't just show up for the party during the execution phase. No way. It's got to be there right from the beginning, way back in the concept and feasibility stages. Why? Because when you have builders in the room with the designers, you make sure the plan is actually, buildable. It stops you from designing something that looks great on paper but is a nightmare in the field. It's all about preventing those nasty, expensive surprises later on.
And here you can see how that schedule literally matures over time. You start in the concept phase with what's called a Class 5 schedule. It's pretty high level, just big milestones. But by the time you hit execution, you're working with a Class 1 or 2. This thing is packed with detail, it's resource-loaded, and it's what you use for day-to-day, even hour-to-hour tracking. It becomes the super detailed roadmap for the entire project team.
Okay, so we've got this plan that gets smarter over time. Great. But how do you actually connect that high-level strategy with the folks wearing the hard hats? How do you make sure the plan is what's happening on the ground? Well, there are some really specific strategies for that, for making sure everyone is marching in lockstep.
It really boils down to 3 core strategies. Think of them as the 3 pillars holding this whole thing up. Number 1 is your constructability strategy. Number 2, a really smart way of doing work packaging. And number 3, a perfectly synced up procurement and logistics interface. Let's break down each one.
Now this graph is so important. It tells you everything you need to know. See that? At the very beginning of a project, your ability to influence the design is huge, and the cost to make a change is tiny. But wait until you're actually building, and the whole thing flips. Suddenly, even a small change can cost a fortune and cause massive headaches. This is why getting those construction experts in early is an absolute game changer.
And that's where the first pillar, the constructability review, comes into play. It's basically a formal process where you get experienced construction pros to look over the engineering drawings. Their only job is to ask, can we build this better, safer, or faster? Maybe they'll see a way to simplify a complex weld or change a layout so it's safer to work in. A big one is modularization. They might say, hey, instead of building this piece by piece in the rain, let's build this huge section in a factory and just truck it in. It's all about making the design work in the real world.
All right, pillar number 2, advanced work packaging, or AWP. The best way to think about this is like meal prepping, but for construction. You take the whole project scope and break it into big chunks called construction work packages. Then you break those down into small, bite-sized tasks called installation work packages. And here's the magic. Each IWP is a complete kit. It has every drawing, every bolt, every tool, and every permit the crew needs for that one specific job. The goal? No one ever has to stop working to go look for something.
And that brings us to the third pillar, logistics. It's simple, really. The schedule has to be the boss of when materials show up. It sets the required on-site dates for literally everything. The planners and the procurement folks have to be totally in sync to make sure stuff arrives exactly when it's needed. Not a week early, where it just clogs up the site and gets in the way, and definitely not a day late, where a whole crew is standing around waiting. It's like a massive, just-in-time delivery system.
Okay, so you've got this amazing integrated plan. Everyone's working together. But how do you know if you're actually winning? How do you know if you're on track? That's where performance monitoring comes in. Because as they say, you can't manage what you don't measure. And the absolute gold standard for measuring progress is something called Earned Value Management, or EVM. Now, it sounds complicated, but the concept is brilliant. It's so powerful because it doesn't just look at how much time has passed or how much money you've spent. It pulls everything, your scope, your schedule, and your costs into one system to give you a single, honest look at how your project is really doing. Really, at its heart, EVM is just a simple comparison. On one hand, you've got your planned value. That's how much work you plan to get done by today. On the other hand, you've got your earned value. That's how much work you actually got done. You just compare those two numbers. That's it. That simple comparison tells you, without any guesswork, if you're ahead of schedule or falling behind. And from that simple comparison, you get super useful metrics like the Schedule Performance Index, or SPI. Think of it like a grade. An SPI of 1.0 means you're right on track. If it drops below 1, you're behind schedule. This, plus keeping a close eye on your critical path and something called float erosion, which is basically your schedule safety cushion shrinking, all of this acts like an early warning system. It lets you see a problem when it's still small, so you can fix it before it blows up into a crisis.
Now, for what is maybe the most complex, most critical moment in the entire project, this is the big one. It's the handover. It's that moment when the construction team says, we're done building it, and hands the keys over to the commissioning team, the people who are going to bring this whole thing to life. And look, this handover, it's not like you just flip one giant switch. It's a very careful, step-by-step process. It begins with C1, which is just construction complete. Then you move to C2, or pre-commissioning. That's where you start testing individual pieces of equipment. After that comes C3, wet commissioning, where you're running fluids like water through the systems to test them. It's only after you've gone through all these checks that a system is truly ready to be handed over.
The official document for this handover is called the Turnover Completion Package, or TCP, and it's way more than just a stack of paper. Think of it as the project's birth certificate. It's the collection of all the legal and technical proof that a system was built to spec, it has been thoroughly tested, and it is absolutely safe to operate.
But before anyone signs that TCP, both teams do a final walkthrough and create what's called a punch list of any little defects. These items get sorted into categories, and the ones you have to pay attention to are Category A. These are the absolute showstoppers, anything that's critical for safety or for the system to even run. And the rule is simple. Every single Category A item must be closed out before that handover can happen. It is the final non-negotiable quality gate.
So when you pull this all together, you see that making this work really depends on everyone knowing their part to play. It's all about clear roles and a shared mission. Let's do a quick rundown of the key players.
You've got the project manager who owns the whole integrated plan and keeps everyone pointing in the same direction. Then there's the scheduler, who's basically the guardian of the critical path, the one sending up flares if things are going off track. You have the construction manager, driving the action on site and feeding that real-world progress back into the system. And of course, the engineering lead, who makes sure all that smart constructability feedback gets baked into the design early on. See, every single role is a vital link in the chain.
Which brings us to the final question, one for you to think about on your own projects. When you look at your project plan, what do you see? Is it just a static document, a checklist of dates and tasks sitting in a folder somewhere? Or do you see the living heartbeat of the project, a dynamic system that connects every single decision, every team, and every action, all the way from a rough idea to a running facility? Because that's the real difference, isn't it? The difference between a plan that collects dust and a plan that actually delivers.